in continuation of the first part of enzyme inhibition. Yes, this is the second part. We have already learned types of inhibitions. First as reversible inhibition and the second one is irreversible inhibition. Irreversible inhibitors. The inhibitors binds covalently with the enzyme and inactivate them, which is irreversible. Now the binding between the inhibitor and the enzyme is covalent. That is, a strong bond is formed between the enzyme and the inhibitor, and thus that enzyme inhibitor complex cannot be broken down back to free enzyme and inhibitor. These inhibitors are usually toxic poisonous substance, as once bind with the enzyme, the inhibitors will never get removed from the enzyme, and the enzyme is of no use from then onwards. Example for this irreversible inhibition is iodoacetate. Iodoacetate is an irreversible inhibitor of the enzyme like papain or glyceraldehyde 3-phosphate dehydrogenase. Iodoacetate combines with sulfhydryl group at the active site of this enzyme and makes them inactive. So this iodoacetate, it binds with the SH group of the enzymes papain and glyceraldehyde 3-phosphate and thus makes it inactive. Irreversible inhibitions are sometimes known as suicide inhibition. In this case, the original inhibitor is converted to more potent form by the same enzyme that ought to be inhibited. The so formed inhibitor binds irreversible with the enzyme. This in contrast to the original inhibitor which binds reversible. So what happens is that suicide inhibitors these are nothing but the irreversible inhibition. Irreversible inhibition is which forms a covalent bond which cannot be broken, but that original inhibitor, it is converted to a more potent form. So inhibitor is converted to one more potent form by the enzyme, and now that potent form binds to the same enzyme and thus it is known as suicide inhibition. Why? As the potent form is formed by the same enzyme. The enzyme itself forms the potent form and then that potent form binds to the enzyme, and I can say that enzyme prepare its own suicide chemical. So one chemical is converted into the second chemical, and that second chemical as conversion takes place with the help of enzyme, and that second chemical inhibits the same enzyme which is responsible for conversion of 1 into 2. So for example, the suicide inhibition is allopurinol. Allopurinol is a drug which is used in treatment of gout. This is your original inhibitor, that is allopurinol. Then and the inhibitor enzyme is xanthine oxidase. This allopurinol is converted into alloxanthine by the enzyme xanthine oxidase. And now this alloxanthine is more effective, that is effective inhibitor, and this alloxanthine will bind to xanthine oxidase in irreversible form. And thus it is known as suicide inhibition. The third type of inhibitor is allosteric inhibitor. Allosteric inhibitors are the inhibitors which binds on allosteric sites. Some of the enzyme possesses additional site known as allosteric site besides the active site. Other than the active site, some enzymes have sites which are known as allosteric sites, and the enzymes and the inhibitors which binds to this allosteric sites are known as allosteric enzyme. Now this allosteric enzymes are unique places on the enzyme molecule. Certain substances referred to as allosteric modulators binds at the allosteric site and regulate the enzyme activity. It's not always inhibition at the allosteric enzyme. This allosteric site, that is the other side, may be positive, may be negative. The enzyme activity is increased when a positive allosteric effector binds at a positive allosteric site known as activator site. On the other hand, a negative allosteric effector binds at the allosteric site called inhibitor site and inhibits the enzyme activity. There are two sites, I can say. Allosteric site has two sites, either an activator site or a inhibitor site. There are two sites, activator site or inhibitor site. If the enzyme is binded with on the activator side, it is known as allosteric effector, positive allosteric effector, and if it is binded to your inhibitor side, then it is negative allosteric effector. So here we are done with three types of inhibition or three types of inhibitors that are reversible, irreversible and allosteric inhibition. So reversible inhibitors can be divided into competitive, non-competitive. Irreversible is also known as suicide inhibitor, and the third form is allosteric inhibitors. So here we'll write the answer in the form what is enzyme inhibitors, what are the importance of enzyme inhibitors, then three types with example. In first reversible of competitive, non-competitive, we'll draw the graph of Km and Vmax with respect to MM equation and Lineweaver work plot. The important question for this topic is explain enzyme inhibition, which can come for 3 marks and 5 marks. If you have any doubt regarding this chapter, you can contact me personally on my WhatsApp number. Thank you.